Hi everyone, welcome to NetGate Chemistry. So in the previous video of coordination chemistry, we were studying about the first type of isomerism, that is structural isomerism. And in structural isomerism, we know that it was of 5 types, out of which we have already done the 3 types of structural isomerism, that is ionization, hydration and linkage isomerisms. So we are going to start today with the 4th type of structural isomerism, which is the coordination isomerism. Basically, the salts that contain complex cations as well as anions these are going to show the coordination isomerism. So what happens basically, in order for these structures to show coordination isomerism, there should be complex cation and complex anions. So for example, we have PTNH3 PTCl4. This is a type of salt in which we have complex cation and also complex anion. So these type of salts in which we have complex cation part also and complex anion part also, these are going to show the coordination isomerism. So for example, this is one isomer, one coordination isomer, and the other one could be PTNH3 and PTNH3Cl3. See, both of them are having same molecular formula, but the coordination sphere for complex cation and anion are having different ligands. So this is the coordination isomerism in which different ligands will be attached in the complex cation and complex anion spheres. So this is about the coordination isomerism. Now we'll move on to the 5th type, which is the coordination position isomerism. See, the coordination position isomerism is shown by those complexes which contain bridging ligands, and this arises when non-bridging ligands which are attached to the central metal ions, these are differently placed around the central metal. So this we can understand better using an example. So suppose I am taking an example. Okay, so if you want to take an example, what you have to remember is that there should be bridging ligands present. So suppose I am taking 2 cobalt metals and we have bridging ligands NH2 and O2, and these are the non-bridging ligands NH3 4. These are the non-bridging ligands, this one and this one. These are non-bridging ligands and this and this. These are bridging ligands. So what happens here? See, what we have to do is we have to see for the non-bridging ligands. These are the non-bridging ligands. Their orientation around these metals will be different. For example, this is the first type of coordination position, isomerism. Second type could be like this: cobalt, cobalt, O2, NH2, and these ligands will be attached differently. Suppose NH33Cl, 1 NH3 and 3Cl. This is the second coordination position, isomerism. Also there can be third one, cobalt, cobalt, same bridging ligands, NH2, O2, and non-bridging ligands will be attached differently. NH3, suppose this is now 2, Cl is also 2, here also ammonia 2 and Cl 2. So this is the third type which could be present. So this is about the coordination position isomerism, in which the non-bridging ligands, these non-bridging ligands will be oriented differently around the central metal. So this is about the coordination position isomerism. So this is all about the structural isomerism. With this, the structural isomerism part is over. This part was actually really very easy for us to understand, but the main part is the next, which is the geometrical and optical isomerism, right, which comes under the category of stereo isomerism. So that part will take a longer time to understand, and that is very important part. Also you need to have three-dimensional analysis of the given compound, so that you can find out where the plane will be present, where the center of inversion, like that, from where we have to cut the molecule, like that we have to find out. So that will cover in the next topic, which will be the stereo isomerism, right? So before ending this video, I wanted to tell you guys something, that this playlist of coordination chemistry is going to be really long, because coordination is a lengthy topic. I don't want to skip on any of the concepts, so that's why we are going to have so many of the videos under the coordination chemistry playlist. You just need to be patient. And one thing you can get sure about is that you will be able to answer at least 60 to 70% of the questions which are going to come in the exams of CSIR NET, IIT JAM or GATE. So if you want to attempt at least 60 to 70% of the coordination chemistry, because 100% nobody can attempt, right, except for the few exceptions. So if you want to attempt a major chunk out of the coordination chemistry section, so you need to be a little more patient, and you have to go through all the videos, or at least you can, using the thumbnail you can know what are the various topics which you have to cover. So you have to cover all the topics under the coordination chemistry, because now coordination chemistry questions are leveling up. So you need to have a thorough knowledge about the concepts under the coordination chemistry part. So that's why there are so many parts in coordination chemistry playlist video. So I hope you understand that, and you are not getting carried away after seeing so many of the videos under coordination chemistry. I'm just trying to give you guys all the possible content which I can give under the coordination chemistry part, so that you are not skipping on any of the concepts, and no question is going to be new for you guys, that you have to think that supposingly you have not done these type of concepts. So you will be confident enough to at least attempt all the questions and get through at least 60 to 70% of the questions by yourself. So this is the main motive for me, that you guys should be able to attempt the questions. So with that being said, thank you so much for watching, and that's it for this video. Okay.